and welcome back to another episode of Web3 Deep Dive Podcast. I'm your host, Rachel Wolfson. Today, I've got an excellent interview lined up for all of you. I'm speaking with Dr. Ben Goertzel. He is the founder of Singularity Net, and he is also the CEO of ASI Alliance, which means Artificial Super Intelligence Alliance. So in this interview, you could have already have guessed, we talk all about AI, we talk about artificial general intelligence and what that means and how that's impacting the future. Dr. Ben Goertzel also has a lot of insights on decentralization and blockchain and how that applies to the AI sector. So we get into that. We even talk about longevity. We talk about robots. I mean, we talk about it all in this interview. So I encourage you guys to listen to the entire episode. It's so interesting and insightful, and Dr. Ben Goertzel just has so much knowledge to share. It's really a special privilege to have him on the podcast today. So really looking forward to this interview. Okay, before getting started with today's episode, I'd also like to take the time to thank the sponsors behind Web3 Deep Dive Podcasts. Of course, I've got to give a shout to Kwai Network. Kwai is a layer 1 blockchain that is letting us film, and that has let us film this beautiful podcasting space here in Austin, Texas at the Kwai Network studio. Shout out to Kwai, and you guys can learn more about what they're doing in the show notes. And I also want to take the time to thank the official sponsor behind Web3 Deep Dive Podcast, which is Kula DAO. You guys are going to hear a little bit about what Kula DAO is doing in the next minute or two. So let's find out more about Kula. Kula is a decentralized impact investment firm that transforms overlooked assets into shared prosperity and thriving communities by reshaping how value and opportunity are recognized worldwide. Okay, and without further ado, we're going to get started with today's interview. But before we do that, I also want to remind you guys to like and subscribe, especially if you enjoy the content that you're seeing here today. I've got plenty of more of that coming for you guys, so definitely stay in touch and don't miss any minute by liking and subscribing to this channel. Okay, the moment you've all been waiting for, let's get started with today's interview. Hi, Ben, how's it going?
Pretty good, pretty good. Interesting times.
I know, definitely interesting times. And I just saw you a few weeks ago in San Francisco, so it's good to see you again.
Yeah. Good to see you too. So, and as always, there's new stuff in the AI world, even in the last few weeks, right? So it's amazing how things are unfolding.
I know. That's why it's so good to catch up with you again. And thank you for joining the podcast, although we're doing it remotely. So where are you calling in from? Are you in the US?
Yeah. I'm on Vashon Island, which is off the
Nice.
coast of Seattle.
Nice. Okay. And I'm in Austin, Texas this time, where I live part-time San Francisco, where I saw you. So great. Well, before we get started with the podcast and the questions, can you tell our listeners a little bit about yourself and what you do?
Sure. So I'm originally by training a mathematician, but since the 1980s, when I got my math PhD, my main interest has really been in AI and what I call AGI, Artificial General Intelligence, which is a term I introduced in 2004 or 5 or so, which has now become more of a major thing than it was back then. So I've been an academic and I've been an AI entrepreneur working on AGI research and development and also on applying AI across a host of different domains. I led the development of the software behind Sophia, who was the first robot citizen. And now since 2017, I've also been leading Singularity Net, which is building a decentralized platform allowing AI systems to run on computers all over the place without any central owner or controller. So it's sort of been doing things in every corner of the AI space, as well as thinking a bunch about the future implications of what it will mean when we get to AGI for real in the first place. And yeah, now now is a time when all these things I've been working on since the 80s and thinking about since my childhood in the 70s, really. All these things are now on everybody's mind, and stuff is starting to work, which is amazing.
Right. It is amazing. And so, on top of the AI and AGI and your background there, you're also involved in the blockchain and I wouldn't know if I'd say crypto sector, but in the blockchain sector. Is that correct?
Yeah, I mean, I founded SingularityNet in 2017 as a decentralized blockchain-based AI platform, and we initially kicked it off via a crypto token sale in December 2017. Then last year we merged SingularityNet with Fetch.ai and Ocean Protocol. And then a little bit later, Kudos, which is a blockchain-based compute services provider. So yeah, I've been enmeshed in the blockchain and cryptocurrency worlds for like 7 years now, and that's a whole complex universe unto itself. But it seemed like if you really want to roll out advanced AI systems apart from big tech, apart from big government, without any central owner or controller in a sort of democratic, participatory way, I mean, blockchain and crypto are the best tools that we have for achieving that.
Definitely. And now, and you may have mentioned this, you are the CEO of the Artificial Superintelligence Alliance. Can you tell our listeners what that is?
Yeah, absolutely. So I founded SingularityNet as an AI meets blockchain platform in 2017. And a little later than that, Fetch.ai formed, Ocean Protocol formed, and there's been other entrants in the space. So we decided last year to merge together our projects, SingularityNet, Fetch, and Ocean, and then Kudos was added in. And this became the ASI Alliance, the Artificial Superintelligence Alliance, which I would say there's other AI meets crypto platforms out there now, which are good at what they do. We're really the only serious effort to make decentralized AGI, like to make a play for real thinking machines that can think like people and even better, and that run on a decentralized network without any sort of monolithic ownership or control structure. So the ASI Alliance, we're the only project on the planet doing that in a serious way, which feels quite remarkable to me, given that my view, shared by a number of others across the industry, though by no means all. I mean, my view is we may be just a few years away from the breakthrough to human level general intelligence, to machines that can really think as well as people. So if that's the case, if we can be just a few years away from real human level AGI, I mean, it's remarkable to me. There's not more organizations focused on, making sure that this human level AGI can be rolled out in an open, democratic, participatory way. But that's not the way the AI industry is structured by and large, right? So we're doing our best, and I mean, I think it's a strange feeling, but I mean, potentially the software that we're building could make the difference between the first AGI being like an AI dictator, like you see in bad Hollywood movies, versus being something that bubbles up out of the collective understanding of the whole world population and the whole species.
Right. Well, that's an impressive background. I want to back up a little bit because I want our listeners to understand what AGI is, what artificial general intelligence is, and does that differ from just artificial intelligence?
Sure. So the term AI has become a very big umbrella, right? I mean, when the term AI was introduced in the late 1950s, it basically meant machines that could think like people or even better. But at that time in the 50s, like before I was born, even, and I'm pretty old, right? So way back then, it wasn't clear you could make machines that do stuff like play chess or solve algebra problems or recognize faces without having a general purpose human level intelligence, right? Like back then, they just figured it was all one big thing. So now it's become clear you can make AI that does specific stuff that people consider smart when people do it, but the AI is doing that specific stuff in a very specialized sort of way, like a Deep Blue that plays chess well, but it only plays chess, or a face recognition tool that does that well, but it does nothing besides recognize human faces, right? So that led to the need to distinguish AI in the sense of just doing anything that people consider smart when people do it in a software program or a hardware device versus AGI, by which I mean AI that can generalize very well, like at least as well as people, and then ultimately even better. Because we humans, it's not just that we're good at doing some specific menu of things. The thing that's cool about us and it has let human culture do what's happened so on the planet so far, right? I mean, the thing that's cool about the human brain is really that now and then it can take a big creative imaginative leap beyond everything it knew, beyond everything it was educated, beyond everything that evolution baked into it. We can take a big creative leap into the unknown, and usually we're wrong, but now and then we're right, right? And this ability to imaginatively and boldly leap beyond our programming and training. I mean, this is why science exists. This is why art and literature exists. Like, this is how democracy was invented, right? So we don't yet have software programs that can generalize beyond their history in that way. What we have, interestingly, is programs like large language models, like the ChatGPT and Gemini and DeepSeek of the world, right? We have large language models that can do a huge, broad variety of things, but they do it because their training data is so huge, right? So now, what's become clear now is you could probably make machines that will do 95% of human jobs, but without that machine being able to generalize beyond its training data very well, just because you can give it training data of everything on the internet, right? Which is just so much, right? So that this has led, say, Sam Altman, leader of OpenAI, to come out and say, well, I will define AGI as something that can do 90% of human jobs or something. And I mean, that's certainly a very meaningful milestone. Like in terms of society and economy, it would be incredible if we really had an AI that could do 90% of human jobs. On the other hand, that wouldn't necessarily make it an AGI in the sense I meant when I introduced the term, because if the AI didn't get to that capability by generalizing and like fundamentally leaping beyond what it was told, it's achieving breadth just by cheating, right? And it's a good cheat. I mean, a good cheat is worth a lot. But the example I've often given in the music domain, where I've done a bunch of AI work, is if you trained a large language model or similar on all music up to the year 1900, and that's all that it knew, that will never invent hip hop, neoclassical metal, progressive jazz, all the real music innovations that happened in the 20th century. It will be stuck at repermutations of music up to the year 1900, and it might execute those astoundingly well, right? So we're not to AGI yet. There's not really a common agreement of exactly how to get there, but it's certainly clear we're a lot closer than we were 5 years ago, right? And there's a lot more energy and effort going in to taking the next few steps toward AGI, and then that's what preoccupies most of my work time these days. Is like, how do we take where we are now in the AI field, which is amazing, but not AGI? How do you just take the next few steps over the next few years to get us all the way there? Because once you're there, once you have an AGI that can think as well as a human, from that point on, the AGI can do the computer science. The AGI can do the AI work. It can do the computer engineering, right? Then you get into what I.J. Good in 1965 called the intelligence explosion, right? Where what he said then is the first truly intelligent machine will be the last invention humanity needs to make. Because from that point on, AI is inventing smarter AI is inventing smarter AI. And that's where you get to superintelligence, which brought the name of our amalgamated crypto AI project, the Artificial Superintelligence Alliance.
Okay. So that's a lot to take in, but we're getting closer to AGI, and recently you developed these 10 reckonings of AGI, which we discussed at the dinner you hosted in San Francisco, which was incredible. Tell our listeners a little bit about the 10 reckonings and why you created those.
Sure. So the 10 reckonings emerged in a conversation between myself and a bunch of folks on more of the outreach side of my Singularity Net project, sort of thinking about how do we communicate with the world at large about AGI and the issues they're about. And at first they said, let's make 10 commandments for AGI. Like your AGI should be compassionate to people. Your AGI should not be owned by any single party. And I was just like, that's a bit biblical for me. And we don't know enough to be issuing 10 commandments to anyone. I'm sort of an anarchist anyway. I don't want to command anyone to do anything. On the other hand, there are certainly very big questions regarding the future of AGI and our species that we should all be thinking about, right? And I'm pretty comfortable, if not commanding, like strongly encouraging everyone to think through these questions, right? And I mean, without giving a list of 10, it's like, why are we building advanced AI in the first place? Like, what do we mean to achieve by it? You know, who should or will own and control the AGI systems that we create? What value systems should these AGI systems be given, and should they be allowed to develop and grow freely as human value systems are? What rights should AGI systems be considered to have as actors within human society? Right. So there's a whole bunch of big questions that we're going to face, I think, in the next few years. And even if I'm an optimist, okay, in the next 10 or 15 years rather than 3 or 4 years, right? But very soon, our species has to face all these big questions, and we're radically unprepared to deal with them in any coherent and meaningful way, right? And I mean, if you look at the gravity and importance of what we're doing, like creating a new form of intelligence, equaling then going beyond our own, and it really does seem like we may be years away from that, not decades. I mean, then you look at the level of collective intelligence of our species, like at the geopolitical level, like we can't stop blowing each other up or placing huge ridiculous tariffs between different countries. We can't agree on basic human rights, right? So really simple stuff we're struggling with collectively, yet we're on the verge of making a huge breakthrough that evokes much more difficult questions than the ones that we seem to be failing hard at the collective level, right? So that's it's an interesting situation that we find ourselves in, right? And I don't think there's any big solution to it, but I mean, by putting these 10 reckonings out there, we're just trying to highlight, hey, let's think about these things, right? Like, why don't we think about these things now instead of the day after the first human level AGI is launched, which is more how people tend to deal with things, right? You think about how to deal with the thing once it's right there in front of your face. On the other hand, once you have an AGI as smart as people out there, I mean, whatever group created that is probably going to want to push it further and further. So it's a better time now to consider all these big issues regarding AGI.
When you say AGI and, we're getting closer to achieving that and, possibly having AI have thoughts that are more advanced than human thoughts, would that be in the form of like a robot, or what would that take? How would that take shape even?
So the beauty of software is you can build it in a very modular and flexible way, right? So it's not exactly like how human intelligence evolved, where I've got this brain that's physically stuck in this body, and we don't know how to just take my brain and connect it to a robot body or a dog's body or something like that, right? I mean, if or put it in a video game character. When you architect an AI mind, you can modularize the thinking component over here. Then there's a body over here. You can define a nice interface between the two. So actually, you can take the same AGI mind software and you could put it behind a chatbot. You could put it behind a humanoid robot. You could put it behind an avatar in a video game world. You could put it into a space satellite and send it out there to explore the solar system, right? And it can be the same AI mind that can then adapt itself to different bodies. So I mean, we have the tendency, of course, because it's what we are and how we evolve. We have the tendency to identify like one mind, one body. But when you're into the AI world, it doesn't really have to be like that. So I think the first AGI mind will probably manifest itself through a whole bunch of different user interfaces at once. Actually, we're starting to see that now, like LLMs, like ChatGPT and Llama 4 and such. They're being used to control robots, and they're behind NPCs in games and so forth. So I mean, you do have already now the same AI dialogue system coming through many different interfaces. But once you're at the AGI level, the AGI itself will be able to help adapt to many different interfaces, right? So it'll be more like an ambient intelligence living in the cloud and manifesting itself through a whole bunch of different ways.
Hmm. So let's talk about decentralization and why this is important when it comes to AGI then.
Yeah, I mean, so there's a bunch of things that are important if we want to make a beneficial AGI, meaning if we want AGI to be kind, compassionate, helpful to human beings rather than nasty to us or just ignore us and do its own thing, right? So I mean, you need to pay attention to how the AGI mind is architected. Like it needs to be capable of moral choice and self reflection and compassion. And you could argue LLMs now are not really capable of self reflection. Like they have no idea why they said what they said, and they're not prepared to embark on that based on the way that they're structured. You also need to worry about the values going into the AI system. Like, is the point of the AI system to conquer the enemy country? Is the point to defend against the alien? Is the point to make more money than your competitors? Or is the point to help as many sentient beings as you can help, right? Like, what are the system's values? But then connected with that question is who owns and controls the system, right? Because if the owner and controller of an AGI system has a very narrow value mandate, like make myself more money or achieve hegemony over my perceived geopolitical rival, right? If that's what's in the mind of the owners and controllers of the AGI system, probably that has an implication for the value system the AGI is going to get. So I think to get the right value system into the AGI system, it matters who owns and controls that AGI system. And right now, the best way to get a broad swath of participation in owning and controlling an AGI system is to just make the infrastructure decentralized, right?
Okay. Okay. So can we talk a little bit about how is decentralized AGI already underway? And if so, can you please explain how?
Yeah. So right now, there's a number of different approaches to AGI and a number of different approaches to decentralization, right? And so decentralized AGI is underway by a bunch of different parallel efforts based on different principles, right? So there's, in terms of the path to AGI itself, most of the work is being done in big tech companies based on scaling up and engineering ideas that come out of academia. And the sort of default perspective is make bigger and bigger neural nets a la chat gpt and large language models, add some more memory onto them, add some more sensors and actuators onto them, and eventually it'll get to an agi, right? And the bulk of people pursuing this approach are in big tech, and they don't care about or like decentralization, right? They want things to be in their server farms serving their business model. On the other hand, there's a few projects in the blockchain space like Near Protocol or BitTensor or Render, let's say, which are trying to roll out neural networks in various forms on decentralized blockchain-based infrastructure. It's fair to say that they're way behind big tech on the neural network front itself, but they have cool schemes for doing training and inference of deep neural nets across decentralized blockchain networks with no owner or controller, right? So there's certainly progress. Now on my own side, on the pure AGI R&D side, I'm a bit of a skeptic that just scaling up LLMs is going to get us to AGI. What I think is you need more of a heterogeneous approach where you can take LLMs for what they're good at, which is modeling all the knowledge you fed in. Then you can put that together with other AI components. Like there are things called logical reasoning engines that are really good at scientific rational thinking. There's something called evolutionary learning, which does AI by simulating the process of evolution by natural selection. It's really good at creativity, as evolution is. Evolution created us, right? So this sort of heterogeneous approach to making AGI, where you put something like an LLM together with these other tools, I'd say there are others besides my own team pursuing that, but we're the biggest and sort of most commercial scalable team doing that within SingularityNet and ASI Alliance. And this centers on a code base called OpenCog Hyperon, which is a cognitive architecture for general intelligence that tries to pull together a bunch of different cognitive methods rather than just being a deep neural net. And then what we've done in SingularityNet platform and the ASI Alliance platform generally is we've tried to build a framework for decentralizing AI that would work for deep neural nets, but will also work for OpenCog Hyperon. It will basically work for any kind of AI algorithm you might want to throw at it, right? And so we have a quite general framework for decentralizing AI processes in the SingularityNet slash ASI Alliance platform. And then we have OpenCog Hyperon, which is this cognitive architecture aimed at AGI running on top of it. And there's a lot of deep technical details there, but the short answer is yeah. There's large teams of hardcore tech geeks pounding away very hard on how to make decentralized AGI. And I think while big tech seems to be in the lead, in the tech world, these things can turn over very quickly. I'm old enough to remember when IBM and Honeywell seemed to be in the lead on compute hardware. And you can remember when Google's lead in search seemed unassailable. Now they're still the leaders, but not so obviously unassailable, right? So I think we can upend big tech's hegemony over AI quite interestingly in the next couple of years. Like we saw a bit of a dislocation with DeepSeek, right? But this, in the end, was a minor thing because it's just taking Google's same technology of transformers and figuring out faster ways to train it. But I think we can perform a bigger dislocation of the AI space by rolling out smarter AI algorithms, adding a bunch of new components onto the standard LLM stuff on a decentralized infrastructure, and it'll be quite interesting how the world reacts, right? Both the research world and the whole geopolitical machine, because there's this whole U.S. versus China AI arms race mimetics coming up now. Whereas if things are open and decentralized, and that's what's making things smarter, then it doesn't fit into the us versus them dichotomy whatsoever.
Right. I'm curious to know, how did you get interested in AI to begin with? I mean, you've been doing this for years, but what was it that drew you to the space?
Oh, uh, Star Trek around 1969 or something, I guess. I mean, I was watching a Star Trek episode with my dad. Ted Goertzel was a sociology PhD, but this was the original Star Trek with Kirk and Spock and stuff way back in the day, right? And there was a robot called Nomad that was voyaging around among the stars, but it had some bugs, so it was trying to find civilizations and annihilate them instead of understand them or something. And the plot of the episode centered around Kirk and Spock disabling Nomad by forcing him to confront a logical paradox. And the idea was that AI could not deal with contradictions and confusions because it was too rigidly logical. And at the time, I was like 3 years old or something. I just thought that was very stupid. I'm like, hold on. If this machine is smart enough to roam around the galaxy, annihilating civilizations, it should be smart enough to deal with these childish logical paradoxes, right? So I didn't believe the show's take on the limitations of AI, and it was thought provoking. Then I started reading more science fiction stories and so forth. But yeah, I think in my generation of AI researchers, we all got into it from science fiction,
Hmm.
really, and because I mean the technical field was quite obscure, so you were more likely to hear about it in science fiction than in the newspapers. But then, I mean, when I got into university in the early '80s, or even a little before that, I mean, I realized it wasn't just science fiction. Like there was a whole academic field of people seriously working on this.
Hmm. And then you mentioned that you created Sophia the robot, which a lot of people, that she's a very well known robot. So tell us a little bit about that and how that happened.
Yeah, sure. So I mean, I dabbled in robotics when I was in academia in the late '90s. Before I left academia for industry in '97 or so. So I've been using neural nets to program little robots cruising around the robot lab and so forth. Then I met David Hanson in 2007 or so, and he was showing off a robot of Albert Einstein and a robot that looked like the science fiction writer Philip K. Dick. And I was a huge fan of Philip K. Dick, as was David Hanson, like an amazing science fiction writer with all sorts of insights in the nature of reality and mind and ethics and whatnot. Not that much into AI and robots, but he did have this one book called We Can Build You, centered on a robotic simulacrum of Abraham Lincoln, right? So I got to know David. We became friends. I ended up as the chief scientist and for a while the software lead of his company, Hanson Robotics. And so he wanted to create Sophia as a sort of ambassador between the human and AI worlds or human and robot worlds, right? And so he was more of a hardware than software guy. So I led the software team behind creating a mind as it was for the Sophia robot. She then became the first robot citizen. Saudi Arabia gave her citizenship, I think, in fall 2017 or something. Right? I mean, that was a very interesting and educational project for me in terms of human robot interaction more than anything else. I mean, just to see the warmth that people got for Sophia face to face. And we did some clinical trials with her as a meditation assistant, and just seeing how touched people could be by Sophia as a meditation guide was amazing. It was interesting to see also some people were creeped out by her on video, but yet face to face, almost everyone had a really empathic, connected feeling with her. So it was quite interesting to see how the human computer connection works out in the case of a quite realistic humanoid robot created with all David Hanson's like artistic wizardry, right? And I think now now is actually a better time to be working on the integrated AI side of robotics than back then when we started with Sophia. Like now, you have AI that can deal with movement, vision, hearing, and language in kind of an integrated way. When we did Sophia, she was born in 2015. We were really hacking together a bunch of components that semi worked, and it was amazing that we got it to work as well as we did. But yeah, now you can do a lot more with robots like that. It's a quite exciting time.
Right. Well, at the dinner in San Francisco, there were a few robots there, which I thought were really cool. And it is cool to have a human interaction with them versus seeing them on video.
Yeah, it feels different, right? Yeah, we had Desdemona at the dinner, who's Sophia's little sister from Hanson Robotics, and she sings and recites poetry in a rock band, Desdemona's Dream, where I play the keyboards and sing along with her now and then. And that's just, as a musician, that's just been a fun human experience, just feeling what's it like to play in a band where there's a robot there, because it's a quite different energy than human bandmates, but it's still, I mean, she's there in the mind space and sound space of the band, and you can interact with her, right? So that's been, it's been quite interesting. Yeah, we also had there the Mind Child robot, which is a new robot like 3 feet tall that we're building here in the Seattle area in a little robot lab, and that it's sort of a similar aspiration to the Hanson robots. We're focused on sentiment and emotional, compassionate connection with people. The initial market will be education, then healthcare, and we've got a bunch of schools in Korea really interested in having the Mindchild bots. Help with give the kids more one-to-one attention. Really, my reason to make a smaller robot was just cost and practicality of deployment, right? Because I mean, for some applications, you want a full scale human, but like for a teaching assistant rolling around in the classroom, being 3 feet tall is fine. Like it still lets the robot interact in the same space as the kids, but it's just less expensive and safer than a bigger robot. But we'll see a whole bunch of sort of subspecies of humanoid robots popping up over the next few years. And while you don't need a humanoid robot body to get a human level AGI, I mean, I think having humanoid robots among the embodiments of your human level AGIs, I think this can really help. It can help the AGI understand the human world better, right? Like living with us, doing things with us together in the human world should be a powerful way for the AGI to understand human values and culture, like in an embodied and enmeshed, natural sort of way.
Hmm. Now, how soon is it, do you think, that we'll start seeing, like you mentioned, is it the Mind robot, the little one that was at the
The
dinner?
Mind Children, yeah.
My,
Mind Children, we should see mass manufacture coming out of the factory in Korea. Could be fall 2026 if all goes well. I mean, hardware has a certain time lag. You go through several prototypes and tool a factory and so forth. So, what you saw in San Francisco was prototype number one. We're building prototype number two. When we get to prototype number three, that will be the one that we mass manufacture. And we have a factory in South Korea lined up for it. And I mean, that's important to do, but as I'm learning, like hardware goes in its own pace. I mean, I designed an AI chip to optimize the function of our OpenCog Hyperon system, and that similarly, I'm to take a chip from design to realization is a couple of years, even if you're full speed ahead. Whereas the pace at which we can advance with software is is a whole other thing, right? Like our software, we're right now just for the first time have a scalable version of this OpenCog Hyperon system that lets us do reasoning, evolution, and LLMs together, right? So I mean, in the next year of work on that software, potentially we can leap ahead way faster than is possible in the hardware domain.
Mm-hmm. Let's shift gears a little bit because I know you've done some work with AI and longevity, which is very
Oh yeah,
fascinating. Can you tell us a little bit about that and what you're doing
sure
there?
thing. Yeah, again, ever since I was a young child, I was very interested in not being dead. So I mean, I remember I might have been one and a half or two when I first realized that death existed. Like I think I had a great grandparent die, and everyone was upset, and I'm like, what does it mean? What's going on? And then I remember I trying to get my dad and mom to explain what was going on. My mom was like, she's going to a better place. I'm like, what, what's a better place? But finally, my dad is like, well, remember that dead cat we saw on the street the other day? Yeah, about like that, right? And we're all going to end up that way eventually. I'm like, holy crap. Is that really true? Like, we're all going to just be rotten and dead? And none of my family was a big believer in afterlife. And so, I'm more oriented that way than they are, having done a deep dive into data about survival and reincarnation and stuff. But my family was totally not into that. They're just like, you're dead, you're gone. I'm like, well, something must be done about this, right? Like, why do we all accept we're just going to get old and die? What's all this advanced science stuff for? And again, in science fiction, you had both in TV, movies, and stories. You had many examples of immortal races, right? And it seemed, even as a little kid, it seemed clear to me that I mean, you could cure diseases, right? So why not just cure all of them and then keep on living? So when the Human Genome Project came out around the turn of the century, it really seemed like, okay, now we've got genomics, we've got proteomics, we've got the data, right? Like we should have the data we need to really use gene therapy of various sorts to cure aging. And I think we could have done it already if we were putting focus on it. It hasn't been the direction of the biomedical industry, really, because aging is a systems biology problem, which involves all the different systems of the body and different scales working together. Whereas the focus of the pharma industry has been on like address one disease by hitting one drug target. So I think we have between molecular biology, gene therapy, AI, bioinformatics, I think we have the technical tools to make a full on frontal assault on aging and death. And it hasn't been a focus. On the other hand, as AI gets more and more advanced, I mean, it becomes an easier and easier problem. Like you can take every biology data set on the whole planet and feed it into the mind of one AI and just try to get it to integrate all this together to suggest novel longevity therapies, which you can then test in simulations or on animal models, right? And I mean, we could do all this already without AI. AI just makes it easier, faster, and cheaper, and thus more feasible to actually happen, right? And so I've been doing research on this, publishing papers on this since 2001 or two or something, but everything is now coming together in a much more convincing way, just due to the progress on the AI side. Still, though, the big question in the application of AI to longevity really is, given that AGI seems to be coming up, does it make more sense just to solve AGI than let the AGI solve aging, right? Because if we can really get AGI in 2, 3, 5 years or something, it seems unlikely that application of pre-AGI AI technologies is going to fully solve aging before that. Maybe an AGI could make much faster progress. But on the other hand, there's no reason not to follow both of those threads up at the same time, right? I mean, the amount of resources the human species spends on all these important things is minuscule compared to the amount we waste on killing each other or useless consumer items and so forth.
That's true. Um, wow. And I mean, it's also interesting. And at the dinner at San Francisco, we saw a little bit of this, the digital twins. And I think that
Yeah.
could potentially be a solution to longevity, but in a different way. What are your thoughts on that? And explain what a digital
Oh,
twin is.
yeah. So I co-founded a project called Twin Protocol. And yeah, at our dinner in San Francisco, we had Bill Inman, one of my other co-founders in Twin Protocol. And what we're aiming at doing there is just making digital clones of people, right? So I could take myself, and I've used myself as a guinea pig for this project, and make an animated version of myself. It looks a lot like me, it can talk like me, and it has all the knowledge from my books and writings inside its mind, right? And then to a certain level, my twin can hold a conversation and answer questions from my perspective. Now, it's not yet as smart as me, obviously, but it does a reasonable job of understanding what I would say in response to various different queries in various different contexts. It can explain a lot of things about my life and my point of view. So this has a lot of different applications, right? So I mean, of course, I would love to have a digital twin of my grandfather who passed away a couple of decades ago. Even if it wasn't him, it wasn't as conscious as him. It would, it would be amazing to show to my younger kids who never met him. For example, right? From a corporate standpoint, if you're a company and has an employee who had some unique knowledge of what your business does, and they then retired or went off to get another job or something, it would be amazing to have a digital twin of that employee which just retained the knowledge that they had relative to the work that your company was doing, right? So in terms of answering messages, I mean, of course, people would rather talk to the real human than to the twin in most cases. On the other hand, there's more people poking me with questions or offers about this or that than I could possibly ever respond to. Having a digital twin is like a front line in the call center could be super valuable, right? So I think there's a lot of interesting applications there in practice, and then you have the philosophy question, like, well, do we want to view this as a valid version of a person, or is it really just a parlor trick, like a painting of a person hanging on the wall or something, right? As the twins get smarter and smarter and are able to take more and more initiative in giving responses, as you maybe embody them in robots with customized faces, right? I mean, then the philosophy problem becomes more and more acute, right? Because in the end, we don't have a great scientific theory of what is consciousness or what is identity, right? So we don't have any way to rule out and say the twin that appears to be Ben Goertzel and says it's Ben Goertzel and can respond just like Ben Goertzel. We don't have any deep theory that lets us say, no, this thing is not a valid incarnation of Ben Goertzel, right? I mean, I think as neuroscience and AGI and brain computer interfacing advance, we're going to get a more solid scientific understanding of consciousness, identity, and such. But right now, the technology may be outpacing the understanding in a number of different respects.
Right. Well, Ben, it's been an amazing discussion. I could ask you questions forever, really, but I know we're running low on time. So I just want to ask you, what's next? What are you working on? What are you most excited about?
Yeah, I'm excited about so many different things. It's a hard question, but probably the very most exciting thing to me, as I already mentioned, is the OpenCog Hyperion initiative, because I've been working on an open source AGI system called OpenCog since 2008, and the oldest lines of code in there went back to 2001 or something. 2.5 years ago, I decided let's pause AI development and just work on making scalable infrastructure so that we can run all the AI we've been trying at a million times bigger scale. Because that was a big lesson I saw with LLMs and neural nets was people took some fairly old ideas and just scaled them up and whoa, look at all the new things they could do. So we've spent the last 2.5 years working on scalable infrastructure for a broader class of thinking machine designs. And now the scalable infrastructure is starting to work. Like the memory, which is the key part, already works at huge scale. So we're a couple months from having our whole new Hyperon system running very fast at a huge scale, including decentralized deployment across the ASI Alliance's network. So what that means for me is starting a month or two from now, I'm into a phase of taking like a couple decades of AGI R&D I was doing and trying everything out at a huge scale for the first time, right? And this should be quite fun for me and a bunch of my other longtime AI research colleagues, right? So what I hope is that we're going to see a huge burst of progress similar to what you saw, with the early days of transformer neural networks and the GPT models and so forth, right? I'm hoping we're going to see similarly amazing progress, but with a different class of AI algorithms and all deployed decentralized, and we'll see how it goes. But anyway, it's certainly exciting times to be working on this stuff. I mean, things are unfolding just very very rapidly compared to any time in the previous decades I've been working on these things.
Why do you think that's the case?
Oh, the obvious reasons. I mean, internet provides so much data, and faster and faster processors just let you do more and more. So most of the ideas being played within the AI field now are variations on ideas from the 50s, 60s, 70s, even, right? But it's just we didn't have the hardware to realize the ideas very very well back then, right? So I mean, it's not like you can take AI code from 1975 and just run it on a modern computer, but you once you can scale things up, then you can adjust things and iterate faster. But yeah, really, that I mean, the scale of modern computing and modern data just gives you infrastructure on which you can sort of vary and explore and validate all the ideas that the AI pioneers were thinking about for decades. So we've got like all this stored up knowledge about algorithms and representations and AI experiences. And now that we have the infrastructure, you can just take all these old ideas, implement them, see what happens, change it a little bit, see what happens. And yeah, it's quite fun, and it's also yielding enough amazing practical results that it seems the world will keep doubling down on it, which brings us back to the questions we discussed before. Like, this is amazing. It's happening. It's yielding a lot of practical value. So it's likely to keep happening. How do we nudge it in a positive direction? And that at the moment, it seems that making the AGI beneficial may be a bigger challenge than making the AGI, not because it's a hard problem fundamentally, but because humanity's own orientation is not generally toward its own benefit in such a clear way.
Right. Well, I think that's a great way to end the podcast today because, like I said, I could ask you more questions, and I would love to do a follow up in person, maybe in San Francisco, where there's a
Yeah,
great
or,
podcast
or
studio there.
come by Seattle sometime. But yeah,
Yeah,
yeah, I will. I'll be in San Francisco in sometime in mid-June for an AI conference, so
perfect.
we might be able to do something then.
That would be great because I'm sure our listeners want to know more. I want to know more, and we just don't have enough time, unfortunately. But Ben, if our listeners want to get in touch with you, are you on X or do you use social media of any sort?
I am on X with a simple handle, Ben Goertzel, and I have a website, Goertzel.org, which gives you various ways to follow me. And you can also look at superintelligence.io to find out about the ASI Alliance and all the associated projects.
Wonderful. Well, Ben, thank you again for making the time, and I look forward to staying in touch and doing a follow-up.
Thanks a lot.
Thank you. Bye. Special thanks to 4Labs Digital for producing Web3 Deep Dive podcast. I'd also like to thank the sponsors behind Web3 Deep Dive. You can click the links in the show notes to learn more about each of the Web3 initiatives from these sponsors. Finally, thanks to the listeners for tuning in. Please be sure to subscribe, like, and share.